Hey everyone, in this video we'll be continuing on with the SageMaker Interest video series. Specifically what we'll talk about today is another concept that I think we sometimes overlook, especially when it comes to the space of ML, but it's pretty important if you're especially trying to productionize any ML applications, and that's infrastructure as code. And for those of you that are new, I'll give a bit of a primer into what IaC itself is, and we'll specifically apply it to do what we've been doing this entire series, just creating a SageMaker endpoint, and we'll kind of revisit some of those core constructs for a second. Before we even get into SageMaker, right? What is infrastructure as code, and why is it so important? It's honestly one of the foundational building blocks of modern day DevOps, especially as you kind of get into cloud deployments and tooling, where you're managing a lot of different resources. Having something such as infrastructure as code is very, very important. And what I mean by this, right, is if you remember, while we're working in these notebooks, while working in this AWS console, trying to create these SageMaker endpoints, trying to make maybe EC2 instances or Lambda functions. In reality, right, in a production environment, you might have a team working together. You might have a team building many different resources. You might have a team allocating different types of kind of compute or database or networking kind of resources that they're working with. And if you just have people doing this via the UI or in their own programmatic fashion without a central place to manage or track all of this, it becomes really impossible to scale. So if you almost envision in this team, right, you have A1 making EC2 instances, and maybe he's using the UI for that. Maybe you have A2 or member 2. I don't know what A stands for. I don't know why I use that here. But just think of these as different kind of teammates. Maybe A2 is making some SageMaker endpoints, and maybe he's using a notebook instance for this. And then maybe someone locally, let's say teammate 3, is making Lambda functions, and he's just doing this in his local environment, which is connected there. These are three different types of resources, and they're all kind of standalone. It's really hard if you're working as a team. These are all things that need to come together for anyone to manage, maintain, or roll out deployments without disrupting someone else's work because we haven't kept a singular track or place of it. That's where IaC comes, where it gives the ability to provide a configuration file of sorts. And oftentimes we'll see that these are actually YAML, JSON files. These aren't really codes, technically code, even though the name indicates that. These are config files where you can essentially define these resources. So rather than having things kind of split across UI or different development environments, you might have a singular template.yaml, and within that, you might have your different resources defined. And within here, you might have EC2, SageMaker, Lambda, obviously simplifying this a lot, but essentially we'll have this single kind of source of truth or template file where people can kind of provision or say these are the resources they're working with. And this is really, really important in DevOps pipelines because it lets for you as a team to collaborate and roll out deployments much more seamlessly. This is really important too when you have different kind of accounts or kind of stages in development, such as dev or prod. You might have some template files in dev for resources, or you might have some template files for production. So in essence, right, infrastructure as code is what enables us to work together as a team and simplify kind of the DevOps experience of managing and maintaining all these different resources that you might be working together on. And this is essentially like crucial, especially with cloud-based deployments where you might have so many different types of virtual resources you're working with, be it EC2 for compute, be it SageMaker for working on some sort of ML resources, or any type of database like RDS or anything of that sort. That's where infrastructure as code is essential. Now, specifically, different kind of popular IaC options you might hear of, and we'll talk on one today. One is Terraform. This is cloud provider agnostic. So there's AWS support, but I believe there's support for other cloud providers as well. The one we'll work with specifically today, because we're in the SageMaker ecosystem, is CloudFormation. This is provided by AWS. There's also kind of a similar service or similar feature known as the CDK, which you might hear of. This enables you to programmatically kind of define these constructs, which then gets synthesized into CloudFormation templates. Don't mix those up. It's just one that lets you define it with Python or Go or kind of SDK level code, whereas CloudFormation is more of that configuration file type that I was talking about. What we'll focus with today is CloudFormation, and we'll specifically apply it to SageMaker to create a real-time endpoint. So the things that you'll learn today with CloudFormation, right, which is kind of the IaC service of choice within SageMaker. What you learn within CloudFormation specifically is what's a stack, what are parameters, and what are resources. And there might be some more deeper nuances that you discover as you play with the service more, but in essence, these are really the three core principles that you need to understand to really get started with working on it. And within SageMaker specifically, right, if we remember, and I'll link our original inference video in this series ahead of time, there's a few constructs that we define. There's model, there's endpoint config, and then there's finally the actual endpoint itself that we're working with. And obviously, all three of these, right? All three of these different constructs are resources that we should be capturing within our template file. So what we'll do now is, right, now that we have an idea of what infrastructure's code is and what SageMaker specifically has resources-wise, and that CloudFormation is our tool that we're going to be using, I'll take you into the console as we always do. I'll take the exact same model that we deployed in the notebook, but I'll showcase how you can do it using a CloudFormation template in a way that's much more production ready, in a way that where you can use it in a real kind of DevOps type environment. So with that being said, let me get out of the whiteboard. Let me hop into the console real quick. And if we see here, I'm still in the SageMaker notebook instance, but you can essentially run this wherever you want. I think I'm honestly just kind of comfortable in this space, but if we come here in that same Git repo, this inference video series subfolder, we'll see that there's subfolders with notebooks and everything else that we're working with through this. What I've done here is there's a few separate files that we can work with. First is the local model.py. And what this does is it creates that dummy scikit-learn model that we did earlier. And it serializes that model artifact into a joblib file. Remember, we're just trying to deploy this pre-trained scikit-learn model onto a SageMaker endpoint. This can be anything that you're working with, essentially. We have this resource, and that creates that joblib file, which is our model data. And then I have another Python script here that is essentially going to upload that to S3. If we remember everything in SageMaker, from a model data perspective or data handling or management, all that lies in S3. So I grab basically that model.joblib, and these are just the model.py serving properties and requirements files, which are all, once again, the DGL container kind of setup, serving stack specific. But it's not really of importance for us to really understand what that is in this video. So we encapsulate and capture all of that in this tarball file, the central tarball file. Just think of this as having all your model data and inference code. We've created that. And now what we can do, right, is actually focus on the CloudFormation template itself that we're working with. So for CloudFormation templates, they can either be a YAML file or a JSON, I believe. I've always used one YAML, so I'm just a little more familiar with that. But essentially, we define this template. I'm going to say this is a CloudFormation template to deploy a SageMaker endpoint. You can take that exactly as is. You can rename it as you want, whatever way you want to work with this. Then there's two central things that we want to work with. And like I said, there's more nuances, smaller things you'll learn as you get more familiar with the service, but these are the two things we want to focus about. And the first one is parameters. So if there's any almost variables that you need your resources to pick up on, like for instance, if you remember, a SageMaker model object has the container and the model data. If there's any kind of hard-coded strings or kind of variables that we need to pass in, this is where we can use it. So specifically for the SageMaker model object, we're going to pass in the model data bucket and the model data location, and we'll pass in the image URI. If you remember, for any SageMaker endpoint, and especially the model object to be created, we need to give the container, which has the model serving stack, that's going to prepare the runtime environment for this. So we pass in the image URI, we pass in the model data bucket, because we need to allow for our SageMaker endpoint to be able to pull down the model data from that bucket, and then we pass in the specific model data subpath, which has our tarball file that we created and uploaded. I essentially used my default bucket here. I made a subfolder, and I passed in this tarball right there. Then I passed in a few other parameters, and this is completely within your control, right? It depends how much you want to parameterize your template. The cleaner, or the best practice, I guess, is to make it as clean as possible. You don't really want anything hard-coded in your resources. So in this parameters, then, I also want to define the specs behind my deployment. I'm going to say the instance type, which is a C5x large, and I only want a singular instance behind it. So I essentially define these parameters, and these are the things that I'm working with, and these descriptions can basically tell other developers what exactly these resources are for, what are these parameters enabling. So make sure to be verbose there. Almost think of it like you're working with someone else where they can read what you're doing. You should follow kind of the software best practices, even in these technology area kind of based deployments. Now, if we come to resources, right, these are the actual AWS objects or resources that we're creating. And traditionally, we've done this programmatically, but we're going to capture all of this within this. The first thing, if you notice here, I'm going to make a SageMaker execution role, and then I pass in type. This type is what tells AWS underneath the hood the type of resource that I'm working with. And here, what I'm going to do is I'm going to give it a name. These commands that you see with the exclamation mark before are just kind of syntactical sugar. I don't know. There's some fancy way of saying that I'm probably blanking on that my professor used to. But essentially, you can take these kind of declarations to basically say substitute the value here. There'll also be ones where you can kind of reference essentially what's happening here within these parameters. So you can learn these commands. I'll link them down below. I honestly don't remember all of them off the top of my head. But you can basically use these commands to kind of reference different types of variables and basically point towards other resources. Here we define the name for the role, and then I basically give it access, right, to that S3 model data bucket so that it can get and list those objects within that bucket. If you remember, we defined the model data bucket here. So we're essentially giving that same role, if you remember, that we used to do with SageMaker.get execution role in the notebook. And I'm saying basically substitute that there, that model data bucket value there. And with this IAM role and policy, we're allowing for SageMaker to work with S3 and ECR right here, where we can pull down that public container image, that DGL container image that we're working. So that's essentially what this first resource is doing. It's giving that execution role that enables for SageMaker to work with the resources it needs to. Then the final three are almost a complete mirror of the exact API calls that we learned about so long ago: the create model API call, create endpoint config, and create endpoint. If you see for the create model API call, we're going to reference that image URI or that container that we're working with. We're also going to reference the model data, so the specific path to the tarball, which has our model serialized model artifact and then for scripts. We specify the mode just like we did a single model. You can imagine for multi-model, you can have it like that. And then we also reference our execution role that we're creating here. So that ARN is that resource identifier there, right? And then the endpoint config, as we remember, all of these are kind of pointing towards each other. So I point towards, if you see in the model name, that SageMaker model, that model name object that we're working with. And then I also specify this is the instance count and type that we want for the deployment specs behind it. I could have probably honestly done the same here. I don't know why I did it there, but you get the point there. And then the final resource we create is the SageMaker endpoint itself, which is just going to reference that endpoint config. Obviously, this is very simple in terms of just creating SageMaker endpoint. You can imagine when you're dealing with many, many resources, or if you scale up, this is probably going to expand in size and get a little more verbose. But if you get familiar with the syntax, this becomes pretty comfortable, and especially with using tools like ChatGPT or Q now, where they're very familiar with CFET templates, you can kind of debug and get boilerplates very, very easily for this. But if I go to the terminal, right, we're going to deploy this using the AWS CLI. And via CloudFormation, what I'm going to do is I'm basically going to point towards the template file, the template.yaml. So that's my central file with my resources. And I've named the stack CloudFormation SageMaker. This should honestly take a few minutes to create because just like if we remember, right, these resources can take some time to provision. So the same thing's going to happen here. But where you can monitor this is if you come to CloudFormation and see the different stacks that are available, you'll see this has already been created because it's gone through. But you can kind of monitor and go through this. So if you'll see from the beginning that when I kicked off that command, you'll see the execution role is getting created, resource number 1 there. The SageMaker model gets created, the SageMaker endpoint config gets created, and then finally the SageMaker endpoint gets created, right? So you can get an understanding. And if I click that SageMaker endpoint resource in the CloudFormation stack, you should see that it's been created in our familiar endpoints console or UI that we're working with. So you can see that directly there. And like I said, you can also see the different options here. You can update your stack if you have additional resources. You can kind of see if you integrate this with a different type of CI/CD tool or things of that sort, right? How this could be very, very powerful in terms of making kind of the development lifecycle simple for your DevOps engineers, especially that are kind of organizing this end to end. So with that being said, right, I think that was mainly what I wanted to cover today. I think yet another concept, kind of like load testing, that sometimes people might look over after just creating SageMaker endpoint. There's a lot of things that you have to consider when actually productionizing these, and infrastructure as code is a thing that's always going to, or a topic that's always going to be there and be consistently needed if you're trying to really productionize your applications, especially in a team setting. So I hope this was a useful introduction to both CloudFormation and also to how we can create SageMaker endpoints via the CloudFormation stack. And I'll be back with more as usual. We'll get more into multi-adapter hosting. That's something that I'm working on right now and stuff. Kind of as a bit of a sneak peek there. But yeah, thank you as always for watching. If you enjoyed this video, feel free to leave a like and subscribe. Any feedback, as always, please leave in the comments anything you'd like to see. Thank you so much, and I will be back very, very shortly.